2,100 or 2,200 people in Maker School right now. You can check that out just by Googling Maker School. And then let me see, what else do we have? Grab the image of me, Alex Hormozy, and Sam Ovens and put that somewhere on the site and add more to the site. Right now it's good, but I want it longer and with pictures of me. Also, see if you could build some sort of animation on the main homepage. I think that would add a significant amount of visual appeal. Right now, it's pretty vague. I do quite like the gradient, though. While you're at it, spin up another 3 and continue doing more iterations, more sections, etc. Okay, as you can see, we're now searching significantly more of the total space of possible websites here, because not only did I spin up, 3 initially to build me these, and then 3 iterations on the one that I liked, I'm now spinning up another 4 based off of the one that I really liked from that previous iteration. And so in that way, if you think about it, like what we're doing is we're taking this idea of what I want, we're testing a few variants, we're seeing which ones actually look good. These are 2 no's. We're spinning up even more. We're seeing which ones of these I really like. Okay. These ones are all no. And now we're spinning up another 4. And, eventually, if you continuously do this process, you'll get to a website or a web app or a property that's like 5 times better, because we have essentially, instead of just picking one option and stopping there, we've really thoroughly explored the space of all possible opportunities and options. And so that's something that agent teams really help with. I know my text is kind of slanting up, but bear with me. And while I'm doing that, we see that some of these are already starting to finish. So iterate scroll just finished. That was pretty fast. Looks like the editorial magazine style site completed with all 13 sections as well. We got the conversion site fully rebuilt with all the changes now. And now we're just waiting on this split. There it is. It's now going to open all 4 of these. And so for 150,000 tokens or whatever the hell I just spent, essentially, I've now been able to draft up what I'd consider to be a pretty clean and sexy website. I have that picture that I was looking for. I have this. I mean, this is great, right? One thing I'm missing is that little video page, but hopefully it's clear. I mean, I could build, websites are just the tip of the iceberg in terms of what you could build. Have my picture here, got my old business partner, Shoma. That's me during COVID doing a little videography shoot. That's when we played bowling down in the Philippines. I mean, like, this stuff's super straightforward. Also, I really like this other editorial site. I might end up just choosing that. That's super clean, right? Those harsh corners and the photos and stuff, very nice. Okay, but if you just use agent teams to design a bunch of websites, you're honestly leaving tons of potential on the table. Most people are kind of uncreative, and so obviously most of the demos you're going to see on the internet are going to be like, watch me rebuild this website 400 ways, like I just showed you. You can go a lot deeper than that. And actually, the number 1 recommended use for agent teams right now, at least my recommended use, is using it on pre-existing repos to do a tremendous amount of research in a short period of time. So what I'm going to do next is I'm actually going to go over here. I'm going to delete all of these websites that I built, because the websites are basically only worth the tokens that they're printed on. Okay, I'm going to full screen this, and then I'm going to say, clone this, and then open an anti-gravity instance inside of it. Then I'm going to paste in one of the repos for OpenClaw, which I've made some rather scathing videos of. OpenClaw is totally open source, which means you can muck around the code, take a peek at the way that things were written, make improvements if you really wanted to, and so on and so forth. Looks like it doesn't know what anti-gravity is. Anti-gravity, the app, it's like VS Code. Okay, cool. And it ended up opening up OpenClaw inside of this. As you see, we are now like in the folder of OpenClaw. It's just, instead of it being on GitHub, it's now on our computer. And so that's just a quick and easy hack. You can basically do whatever the heck you want with these repos. Once you're inside, I'm just going to open in the terminal, because I think I can probably go significantly faster in the terminal. Let me just open this up. Okay, I have it right down over here. I'm going to pop this puppy open, make it go full screen by clicking that button in the top right. And now I'm going to use agent teams to go through this massive, massive file and then make improvements. Taking a look at this prompt, I wrote OpenClaw is great, but there are a bunch of security issues. I don't know exactly where they all are yet, but I want you to find them. First, create a team with 10 teammates to look through the code base very quickly. Split things up logically based on file size, etc. Then spin up 4 agents to document all of the security issues, and a 5th and 6th debate agent that plays devil's advocate back and forth. Use Sonnet for each teammate so as to make use of the longer context window. When you've identified all the security issues, then spin up 1 agent per security issue and make changes. Ensure each agent works only on the security issue it is given to minimize overlap, and if one agent steps on another agent's toes, have them rectify by talking back and forth. Now, I'm not going to fix this code base throughout the course of this video because that'll probably take several hours for it to go through, make changes, and then obviously there's Q&A and testing and so on and so forth. This is pretty similar to the workflow of the creator of this godforsaken repo. And if you're curious about why I have strong opinions on this, just check my channel for one of my videos from like 2 weeks ago or so. But this is pretty similar to the workflow that they're currently using in order to manage things. But suffice to say, you can use an approach like this on basically any open source library, not just to identify security issues, but also to improve the product. You could come up with different product angles. You could have it, go through, spawn 5 agents each that propose different product ideas, and then you could have like debate agents that debate back and forth about why this would not be a good idea. And in doing so, they come to a consensus and improve the quality of the product at the end of the day. So what this just did is it spun up and listed all of the products here, so that I could build a simple and straightforward way of basically splitting this work up. So now we have 10 scanner agents that are running in parallel across the code base. This first one here has 83K lines. The second one has 43, 42, 42, 35, 49. So they're not all the same, obviously, but lines aren't all equal. So maybe this did some additional work behind the scenes or under the hood. Now, this is going to consume a lot of tokens. So you see here, we're already at 1.3 million and counting. And, I'm consuming a fair amount of my own token budget to do this, but I figured it would just be interesting for us to do. If you're operating at like a massive scale like this with dozens, if not hundreds of these things, you will eventually spend several $1,000s on said tokens. And so you need to be prepared for that. Don't spin up an unlimited number of agents if you're not capable of paying the money for said unlimited number of agents, obviously. And be wary that the tokens that you are using here are tokens that, unfortunately, you will never get back. You can't spin this thing up and then ask for a refund on any of these. So be careful, I guess, to make a long story short. However, if you do have the money, you can basically convert it and translate it directly into time, as in time savings. What I've done here is I've taken $1.3 million Sonnet 4.5 tokens, and I basically immediately translated them for probably several hours of my time because I don't actually have to go through this or do this a lot slower with like a more intelligent agent. So now that we've done this, the next step is we've compiled all of these security possibilities, I should say. We're now spawning specific agents all about particular security issues. So we have a command injection and code execution agent, an authentication and authorization agent, a path traversal plus SSRF plus info disclosure agent, crypto plus race conditions plus config agent, challenges findings as not real issues is devil number 1, that's devil's advocate. And then devil number 2 says argues findings are real and need fixing. And so basically these agents are all going to report over to these puppies, and these two are going to debate back and forth between each other to determine whether or not this is something that's real, whether or not this is something that's actually super important. They're going to take different principled positions and attempt to see whether these findings are not real issues or whether these findings are real and need fixing. Usually when you have two agents work adversarially against each other like this, the end result is higher quality. This is actually the core of a big chunk of machine learning, which is what AI used to be called a few years back, not just large language models. Generative adversarial networks were one of the first image models, for instance, and they worked in a very similar fashion. You had something that generated, and then you had sort of like an adversary. And these two just went back and forth until you got a really high quality result. So I can actually scroll down here and see what these two are saying. So these are literally having a conversation right now. These are actually discussing things. Looking at devil number 2, it's sending round 1 its counter arguments now. We're going back here, and they're basically like fighting verbally, mind you. Sticks and stones may break my bones, but AI words will hurt you, to determine which is the best path forward. This message over here, this wasn't mine. This was a message from the team lead. Basically, a devil number 1 responded to team lead saying, hey, here's a key finding. Team lead responded back saying, hey, keep going and let me know when the debate finishes. When it's done, we're good to go. So to be clear here, over the last, I don't know, maybe 15 minutes or so of the specific agent team instantiation, I've spent close to probably $80 or so directly on this one query. And that's what I mean by trading money for time. I mean, like, obviously, if I had a team of developers doing this, they probably would have been more accurate, but it also would have taken them presumably several weeks to do the level of research that this agent was capable of doing in just a few minutes. I traded $80 for that time. And so in some instances, that's worth it. But in a lot of other instances, it isn't, which is why agent teams need to be handled pretty carefully. They're almost like a nuclear weapon, just one aimed directly at your wallet. Now we've done the debate back and forth. The two have had a great conversation. And so basically they found 15 total flaws. What it's doing is it's now spawning 15 fixer agents, one per isolated security issue or grouped when they touch the same file. Now I don't obviously want this to consume all of my tokens, so I'm just going to cancel this and I'll say shut. in caps, shut everything down ASAP. It's not going to shut down all active agents immediately. Unfortunately, just due to the nature of this, the shutdown request doesn't occur immediately. It's not just like we're, Alt F4ing this whole puppy. There's a little bit of time because every individual agent is still in the middle of a query while it's doing the thing. So, you're probably still going to consume a little bit of token usage. Not going to be that crazy, but it is going to be a little bit. But yeah, I've consumed enough at this point to know that this is something that I'm probably not going to want to do unless I'm hell-bent on improving the OpenClaw repo, which I am not. And that takes us to the final module in this course, which is one on Git work trees. Now, Git work trees used to basically be what agent teams are today. Essentially, you could have multiple agents all running on their own individual, what's called GitHub repo or GitHub branch. And in doing so, these agents could all work on individual features, which allowed them to do what they needed to do before ultimately merging back to the main branch. To visualize this for you, imagine we start with a job over here at main. This is our main branch. And then there's some bug. So what we do is we spin up a branch called hotfix. Now this is given to a different agent. We then have another branch called develop, which is given to a different agent. And then finally a branch called feature, which is given to a different agent. So basically what occurs is we have one agent over here extending on this branch, one agent over here extending on this branch, one agent over here extending on this branch, and then one agent over here extending on this branch. And essentially each of these go through their own development process, similar to the agent teams like we just saw here, just managed through GitHub instead of just the anti-gravity IDE. And then when they're done, what they do is they merge the results back into the Mage branch. Now, if you're not a big into programming and you haven't used GitHub before, this idea of a merge can be pretty difficult to understand, but basically every branch just stores a copy of the folder. And so this master folder is basically the same thing as this new feature folder with just a couple of minor differences, and it's usually the new feature itself. So when you merge, what you do is you're just tabulating a list of all the changes between these two, and then you're taking the new changes from the new feature branch and then applying them to the master branch. This merge process can typically be pretty messy, and so having agents around to mediate the merges and so on and so forth can be quite useful. So first of all, I have a really simple website set up here called leftclick-agency. I made this for my own website a while ago, and had AI do the vast majority of the work in a very similar sort of workflow to what I just showed you guys a moment ago with agent teams. And what I want to do is, I want to design additional pages here. One page that's really long is not enough. So in addition to this home page, I also want to design an about page, a contact page, and a services page. And I want to use the Git work tree workflow in order to do this. Now, because I've stored information on what I mean by Git work tree in my Claude.md, which is basically that we use Git work trees for parallel development with Claude Code, where every work tree is an isolated working directory sharing the same Git history, allowing multiple Claude Code instances to work on different tasks simultaneously without interference. Okay, this already knows what to do. The very first thing that it did was it basically took my main repository, which was just called leftclick-agency, and it made three different ones. It made one called leftclick-agency-services. That's a new folder. Another called leftclick-agency-about, which is another folder. And then another called leftclick-agency-contact, which is a third folder. So basically what it's doing now is it's creating new GitHub repositories, new individual feature branches to work on different pages for me. Now, it did this using the agent team functionality. And the reason why I did this is just because it's much faster and they get to work on different GitHub repos simultaneously. The only real advantage to using Git work trees, I think, at this point is just that when you use Git work trees, what you're doing is you're not actually modifying the main folder. Like if you look up here, we're not actually modifying any of this right now. What we're doing is we're basically creating a new folder in our, GitHub repository. And you can see them right over here. And then working in those different folders individually. So for instance, we have leftclick-agency. This one here is my main folder, right? But then we have leftclick-agency-about. This is a new branch that's working specifically on the about. Then we have contact. This is a new branch working specifically on the contact page. And then finally we have services, which is a new branch working specifically on the services page. And so the reason why this is valuable to people that are non-programmers is because you reduce the possibility of two different agents working on the same file, which will occur. You will get what are called agent conflicts over time, naturally, as you have multiple agents working on multiple things in the same base. And the reason why is because files aren't perfect separations of functionality. You'll have one file, and then that file will have like the snippet of a little bit of code that